Well, this session talks about several basic operations with matrix. The first question, what is a matrix? Matrix is an array of numbers arranged in rows and columns. For example, here we have matrix A, and it comprises lots of elements. And each element can be denoted as lowercase a, RC, subscript RC. R here denotes the row number, and C here denotes the column number. And here we have how many rows? We have 2 rows and 3 columns, right? So element AA is in row 1, column 1. Element A12 is in row 1, column 2. So here you can see that in the subscript, the first number denotes the row number, and second number corresponds to column number. Okay, so here is we have a 2 by 3 matrix. That is 2 row and 3 columns. 2 row and 3 columns. Okay, here we have another example. Matrix B, and it has a dimension of 3 by 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And sometimes it's also called square matrix because the row number is equivalent of its column number. Okay, so here is how to read matrix or matrices. And this slide talks about matrix transposition or transpose matrices. The transpose of matrix is to reflect a matrix over its main diagonal. That is, it switches the row and column indices of the matrix A by producing another matrix, often denoted by A prime or A transpose. Let's say we have a matrix A, right? Here we use generic letters and numbers to denote elements in this matrix, right? We have 2 rows and 3 columns. And after matrix transposition, okay, so we say, well, we have A transpose or AT or A prime. What we have here? Well, we have, instead of having 2 rows and 3 columns in the original matrix A, now we have 3 rows, right? And 2 columns in the new matrix. Okay, so the element AA is here. Element A12 becomes the first element in row 2 of the transpose matrix, and A13, the first element in the 3rd column of the original matrix, now becomes what? Becomes the first element in the 3rd row of the transpose matrix. So the first row becomes first column in the transpose matrix, and second row becomes what? The second column in the transpose matrix. So pretty much what transposition does is to flip the matrix like 90 degrees from here, this direction, to that direction. Okay, so 90-degree rotation, 90-degree rotation. And here I can give you a very concrete example. Let's say A is equal to 1, 2, 3, 4, 5, 6, right? 1, 2, 3 is in row 1, 4, 5, 6 is in row 2. How about its transpose? Okay, its transpose, the first row becomes 1, 4, second row becomes 2, 5, and third row becomes 3, 6. So the first row in the original matrix A, 1, 2, 3, becomes first column in the transpose matrix A prime. And the second row in the original matrix A, 4, 5, 6, becomes second column of the transpose matrix A. So matrix transposition is relatively speaking straightforward. Then how about matrix addition and matrix subtraction? So here we have two matrices, A and B. They have to be of the same dimension. That is, the number of rows and number of columns should be exactly equal to the number of rows and columns in the second matrix that's added to, okay? So here we have, for example, right? Matrix A and B, right? Both are square matrix 1, 2, 3, 4, 5, 6, and 7, 8. So the first row and first column of the first matrix added to the first row and first column element of the second matrix. So it becomes what? 6. Same thing for the first row, second column. That is 2 here. From matrix A, added to what? This first row, second column of matrix B. And 2 plus 6 is 8. Right? You see that? So this is a simple extension of kind of scalar computation, right? Single number computation. Here, we're dealing with arrays. Same thing for 3 and 7, we get 10, and 4 and 8, we get what? 12. Subtraction is just a special example of addition, right? Addition. So here, again, we have to make sure that A and B here, the two matrices that are involved in subtraction, are of same dimension. Then we can do element-wise operation, right? So 1, 2, 3, 4 minus 5, 6, 7, 8. What we're going to do, element-wise subtraction. 1 right here, that is the first element, excuse me, first column, first row element, okay? In the first matrix, in the first row and first column element of second matrix, right? If we subtract, okay, 5 from 1, we get what? -4. Same thing for other corresponding elements. Okay, we get 4, -4, -4, -4, -4. Okay, so almost exactly the same as matrix addition. The only exception is that now operation becomes what? Subtraction. Okay.